Well, hello everyone. Welcome back after this great big long break and mess called COVID-19. Uh, we're back to this video thing. I'm sorry about that. I hope to make it work for you. The good news is we're on campus for various courses, and you should feel free to ask anyone any questions from lessons when you're on campus so that you're not always sitting in a vacuum. I know that if you bring questions to me, I will do my best to answer them. If I can't, I will email you. And it might even be for me, because my scatterbrain, it might be best if you email your questions, but also talk to me in person when we get to the college, just so we double cover in case I forget something. But my courses this term should be fairly straightforward. This course is probably technically more challenging. Some students find it difficult. As always, I will give you a long list of review questions, and you know that a lot of the questions that are on the midterm and on the final will come from the review questions. So I don't want you to panic. I want you to relax and listen and try to pick up what you can as we go through the course. Some of you maybe will really get into it and will pick up all kinds of stuff. Some of you are like, oh, why am I learning this stuff? And I'll be truthful, there's stuff sometimes at school that you may never see, but honestly, I try my hardest to filter out the stuff, the fluff, and give you things that we need to know. And one of the realities of greenhouses is that they are a form of technology, and technology means that they're evolving and changing, and you have to keep on top of that, and you have to understand what what the technology means and what does it bring to the table. Uh, for me, that's part of the fun of greenhouses. I love stuff. I love machines, computers, things, and that's what makes greenhouses so attractive to me. Um, Anyways, so this course focuses on some of the theory surrounding how to manage the environment in a greenhouse. Effectively, this course sort of bridges into the winter where Matt continues and maybe reviews some of this, which is maybe not a bad thing because there's some really important concepts. And he also moves it more towards, okay, now I'm going to show you how to use the computer system so you can manage a greenhouse. And some of you will be wondering why, and I can't stress this enough that knowing how to use a greenhouse computer is an essential skill. Um, I've seen too many companies that were looking for a grower that was just a little more advanced with their Priva or Hugendone or Argus computer, and they passed on hiring someone because they just didn't know how to do basic navigation in a Priva. Um, I would encourage you all to advocate when you're taking that course to get time in front of the computer. Matt is a busy guy, but he also, if you pin him down, can sit down with you in his office and let you see his computer system and how to navigate it. And I think that would be a really good thing to do if you're going to take the extra time and energy. But you're going to have to push for that. So, um, what else? This course has a bunch of online quizzes. There's one the second weekend. Um, as always, I release my quizzes Friday evening, close them Sunday midnight, something like that. But if you miss a quiz, let me know. Um, again, I see quizzes as reinforcing learning, not to clobber you and knock your marks back. That's no, that's not what they're for. So if you missed a quiz, let me know. I'll make sure you have a chance to write it. I don't want to have my face on the bottom corner of your screen all the time, especially today when I'm tired. My eyes are all puffy because I just woke up and my coffee. I don't know about you guys, but COVID-19 has just blown my routine out of the water, and I've gotten used to, quite frankly, being lazy. uh, anyways, I really hope you guys are all doing well. Hope none of you or your family or extended family have suffered from getting sick with COVID-19. Um, Now that you're moving into second year, you'll see a lot more of me, and you'll hear me sort of rant occasionally. I think you're used to that maybe a little bit by now, but uh, COVID-19 is something that sort of fits right in with sort of one of some of my pet peeves about our world and the internet and misinformation, and it really highlights how there is a battle for your brain. Oh, for your brains on the internet, and confusing you with contradictory information and stuff like that. And I'm not going to get into the nitty gritties of COVID-19, but what I will do is throughout the second year, we'll do a few research paper reviews in the various courses. Nothing insane, but I want to try to help you learn for yourselves how to find good quality information. YouTube can be a fancy, fantastic thing, but quite often it's amateurs and the information is not reliable. Um, that may be hard to believe. But so there's some things in horticulture that, there's common misconceptions, and I want to set some of those straight. And so some of the papers will be targeting that. Um, but the idea is that, you get in the habit of going to periodicals and reading and looking in professional locations for information, not YouTube. Uh, I look at the cannabis industry right now, and it is struggling so much because there's so much amateur stuff that has somehow made it to the upper echelons of the businesses, and their crops, although recently starting to get better, it's still. Just the other day, I had a grower talk to me. They were complaining about CO2 levels, and they failed to understand that elevated CO2 levels in the summer when you're venting is a pointless endeavor, and no one in their right mind would do it in horticulture. But I have seen quite a few facilities do that because they don't understand horticulture. They think they do because they learned it on YouTube, but they don't understand. So this course will probably help debunk some of those things and set some things straight. So let's get into it. Okay, so why even bother building a greenhouse? Why not just grow in a field? And you see this question asked, and it can be a legitimate question. You look at an traditional organic farmer, they're going to grow in a field. But more and more, you'll see they have a greenhouse for maybe starting their plants or for maybe protecting the crops that are more prone to wind and rain damage, or if they're early for hail damage, or maybe to get crops to emerge earlier, like lettuce and spinach early in the season so they can make a little more money. So from the low-tech organic little farm to the high-tech, high-capacity industrial farm, greenhouses do play a role. But one of the biggest reasons would be light. And this is sort of a classic if you're a Pink Floyd fan or anything like that. You've seen something like this on their albums, but you have white light, which is from the sun, is made up of all kinds of different colors that can be broken up in a prism. That's how you get a rainbow. But light is absolutely critical to growing plants. I think we all know that. But there's some interesting things about light that you should know. And it kind of touches on climate change. And so I thought I would just sidestep into this a little bit and help you understand how that works. Because essentially, the greenhouse effect, and we've heard it many times, really is referring to a greenhouse, right? So if you think of the Earth floating in space, and it's got an atmosphere, which is sort of like having a greenhouse layer over top of it. When sunlight passes through, it hits the Earth and warms it, all right? And that warmth re-radiates at a different, longer wavelength, and it gets trapped and bounces back. And so that's how we trap heat in the Earth, okay? The other thing that does, which is maybe a misunderstanding, is it's not just wavelengths that are trapping, it's also gases. But as far as light being trapped, we call that the albedo effect. So the lower the albedo, the more radiation from sun that gets absorbed by the planet. If it has a higher albedo, it means it reflects more light. So in this picture here, some of the sunlight reflects off the exterior surface, some penetrates further and is absorbed. So reflection helps cool surfaces, right? So example would be snow. So snow reflects sunlight, so it keeps the climate cooler for longer. If you're looking at a greenhouse, sunlight, shorter wavelengths of sunlight pass right through the glass, hit any surface in the greenhouse, the floor, the plants, tables, they warm them, and that warmth then gives off radiant heat. That radiant heat then re-radiates up and bounces off the inside of the glass and is trapped. Really long wavelengths will escape. But so that's how a greenhouse gets hot very quickly, with the albedo effect trapping wavelengths inside. As far as global warming goes, a confounding factor is that air, for the most part, is made of gases that are very light. So nitrogen gas, which has 2 atoms, oxygen, which has 2 atoms of oxygen, those are very small molecules. But when you start adding larger chemicals to the atmosphere, things like CO2 or methane or nitrous oxide from diesel vehicles, those larger molecules, each bond has a spring. And springs can store energy, right? They can start to vibrate and shake. And larger molecules can store energy. So the air itself actually gets hotter. And that is a factor in terms of the strength when we talk about the strength of a greenhouse gas, right? So methane, which is quite a bit bigger than carbon dioxide, is 28 times more of a greenhouse gas, a stronger greenhouse gas than carbon dioxide. And nitrous oxide is 265 times stronger as a greenhouse gas than CO2, because those molecules have bigger bonds, and more of them, which store more energy. So that's one of the things about greenhouse gas, right? We have the albedo effect with light coming into the atmosphere, and we also have gases in the atmosphere that store energy. So that's how a greenhouse gas impacts it. And I don't think this is necessarily shown in Plant Science 1, but when I taught Plant Science 1, I really like to help people understand climate change. And this is probably the most convincing evidence that I can present to someone to prove that climate change is real. I mean, again, we're bombarded with all kinds of things, but cherry trees are sacred in Japan. And the Japanese have been tracking when the blossoms emerge since the year 800 AD. And so that's a long time. And now remember, we didn't have thermometers back then. Thermometers were invented somewhere around here. So how do we track the temperature of the climate historically? Well, the wonderful thing about blossoms on a tree is that blossoms will open depending on various climate factors like rain, light, photoperiod, but most importantly, temperature. And so cherry trees open in a very narrow window, so they're an excellent way to track temperature change. And so if you look, obviously there's variability on this map. This is all sorts of all over the map because of different years and variations, and there has always been variation in the climate. But if you look at the graph, starting in the 1800s, things definitely tighten up. And what do we have here? This is the number of days past March for the blossoms to open, which means the blossoms are opening earlier and earlier and earlier and earlier and earlier and earlier. This goes to 2016. On top of that, the variability that we have seen up to about here is greatly reduced. So the dates and the times are much tighter. And if you look at this in the point of history, what you'll realize is that this is right around the Industrial Revolution, when we started burning massive amounts of coal to build iron. And as we've moved into the 20th century, we've moved to burning gasoline and diesel and natural gas, and have filled our atmosphere with all kinds of carbon dioxide and methane and nitrous oxide, which has raised the basal temperature. And I don't know if you guys have been watching the news. I know there's so much focus on COVID-19, but the Greenland ice shelf has passed the point of no return for their freeze-thaw cycle. and a major shelf in Antarctica has cracked and fallen down. I think it represents like thousands of hectares. This is a definite thing. And if to relate it back to the greenhouse, because the polar ice caps are white, they have an albedo rating that reflects heat. And so once the polar ice caps start to shrink, we lose that albedo reflection and we start to accelerate in terms of our temperature gain. So there's a lot of stuff about climate change that is real. And now, what does it mean? That's a whole other story. I'm not necessarily going to be so alarmist about that. It can mean a lot of different things. I think I'm still optimistic. I don't want to sit here and be pessimistic about it all, but what does climate change mean? I don't know. It might mean that we're more productive agriculturally. It might mean that there's some migration. It might mean that there's maybe more droughts, but it might produce opportunities for us. Maybe we reduce our heating requirements in some of the northern climates. So I don't know. I have no idea. I do know that the planet has been through many cycles and survived, but we also know that humans haven't. So I'm more of the mindset that it's not about save the planet, it's about let's try to save humanity. Because the planet will just go on and worst case scenario, we're done for. Anyways, as far as greenhouses go, after that side step, one of the first and largest greenhouses ever built was in 1851, and it was in what's called the Great Exhibit. So every so many years around the world, we have a industrial exhibition. So in 1986, Canada hosted the World Exhibition. This was in 1851, London did, and they built this massive greenhouse to house all the displays. It was also around a time when plate glass our new manufacturing methods were devised for making plate glass. So flat glass that was optically clear and easy to manufacture. And so this was a demonstration of their abilities, which was pretty impressive. The structure actually burnt down 50 odd years later. But anyways, beautiful structure, the Crystal Palace. So what is a greenhouse, right? It's a simple structure that protects crops from freezing, rain, insects. There maintains a consistent climate. But probably really importantly here, allows for year-round production. So you can have specialized greenhouses that are specific to crops or generic ones for a variety of crops. There's all manner of construction. It's bonkers. You Google it up, you'll see what I'm talking about. But going back to the very earliest forms of a greenhouse, in the wealthy Victorian days of, for example, the Spanish, the Portuguese, the English, from their adventures around the world, they brought back specimen plants and they wanted to grow them. And so they built these sort of lean-tos on their houses that had some form of glass or crystal that allowed light in. And they were often called an orangery, especially in England, because they could grow orange trees and have year-round oranges, which was a real exotic thing at the time. So that's how they first started. Then they evolved into something called a cold frame, which is still used to this day. Cold frame is just simple glass plate frames that are put on an angle over, whoops, it's terrible drawing. You see what I'm saying. They're put over top plants to protect them from frost. If you've ever driven up Highway 400 past Toronto, you go through a flat agricultural area called the Holland Marsh. This is actually a farm in the Holland Marsh, and this is how they start all their vegetable seedlings to plant out into the field. So it's still used to this day. And these are actually wooden frames, which is very low tech and probably not recommended because wood hosts, disease and fungal stuff, but they're doing a very quick turnaround on seedlings, so it's not a big deal. So that's a cold frame. And it's also something very easy to build at home if you want to, protect your garden and start it earlier. Put it down on the south side of your house. Boom, you've got yourself a cold frame. All the way to high-tech greenhouses specifically designed for a crop. This is an example of an orchid greenhouse where if you look carefully, you see there's fans underneath here, and this walkway is a porous space, and the air actually circulates under the crop and is blown through, and there's air conditioning here, so the temperature is cooled via massive air conditioners. That's probably one of the most high-tech type greenhouses you'd come across. Orchids are used to a climate that is incredibly consistent. They don't like wild temperature changes. So orchid greenhouses are very expensive to build and operate. Orchids, ironically, are actually very easy to grow as long as you have the proper facility. There's not many pests that attack them. They don't have a lot of fertilizer requirements. They hardly use water. Very easy to grow. But like I said, expensive. So why producing greenhouses? Well, to keep crops warm in cold weather, to control crop development, right? So sometimes you want to be able to control temperature and photoperiod so you can grow the crops properly. To conserve irrigation water, so we're controlling evaporation, we can collect the water and use it again. Whereas if you grow a crop in the field and you irrigate, it goes down into the ground and it's lost and it's also evaporated away. So greenhouses tend to use substantially less water than outdoor production. They also allow for hydroponic production, which is where a lot of our vegetables are grown that we eat at the grocery store. Tomatoes, peppers, eggplants, strawberries, cucumbers. There's always stuff being added. In Japan, they grow all sorts of melons. It depends on what your market price is and what people are willing to pay. They also allow intensive biocontrol. This is something that oftentimes is overlooked. You can use insects to control other insects, right? We call that biocontrols, or integrated pest management would be the broader title. And you can use it outside in the field, but it's not nearly as effective because your biologicals that you buy will just fly away or crawl away or even be eaten by other predators that exist out in the natural environment. Where in a greenhouse, you can kind of control what comes in and out a lot better, maybe not perfectly, but a lot better. So you can release far more biocontrols and not worry about losing all your money. And they'll be much more effective. So that means you're using less pesticides, which is the case actually. Produce grown in greenhouses is almost pesticide free, mostly. Every once in a while they have to use a fungicide, but that's very rare. This is an aerial photograph of greenhouses in southern Ontario down towards Kingsville, Leamington area. That's just one section. There's the largest concentration of greenhouses in Canada and North America, in fact, is in that area. Very big, very high tech, highly productive. But if you want to go bonkers, this is a place called Almeria, Spain. Now this looks like snow or ice on the side of a peninsula, but everything that's white that you're looking at is a greenhouse. I kid you not. And talk about albedo effect. Because the greenhouses reflect light, it's actually consistently 2 degrees cooler in Almeria than other parts of Spain. Let's look a little closer. Yeah, there you have it. That's the definition of greenhouse insanity. Almeria, Spain produces the vast majority of tomatoes, peppers, cucumbers, strawberries, and amongst other specialty crops like lettuces and spinaches for the European and Eastern European and Mediterranean markets. They have a very good climate, they have expertise, they have labor, so they're able to produce a ton of stuff. What kind of things are grown in greenhouses? We've talked about that already, but lots of stuff. What are the priorities for a greenhouse design? So basic functions: cooling, heating, protecting, preserving water. Oftentimes your geographical location has an impact. And also, are you going to grow seasonally, just a couple of months a year, or are you growing year round? Those are things that sort of factor in. But some of this you'll be touching on with Jay in your greenhouse construction class. So I don't want to spend a lot of time on it because we're focusing mostly on light today, but I'll just touch on this because it sort of puts in context the light, right? So the structure you're building depends on the value of your crop, right? Is it a low cost crop? You're not going to get a lot of money for it, so you can't afford to spend a $1 million on a greenhouse to grow a crop that's not worth much. What are the requirements? Is it light or energy reduction for your particular crop? What are the snow loads, right? Are you in a heavy snow area or a high wind area? What type of material do you want to cover with? How tall will your crop be? So there's all sorts of considerations. But looking at that, what do you think the most important design factor is for a greenhouse? Typically, greenhouses have to make money, unless you're a government greenhouse, everyone that has one has to make money, which means you have to somehow generate enough money to cover your costs. So things like labor, energy, crop quality, crop losses, your yields, all these things factor in to a greenhouse construction. So the operating cost is labor is definitely up there. Energy efficiency is second. So as far as energy efficiency, light plays a big role, right? So looking at some of the classic greenhouse designs, we call these Venlo in the greenhouse industry. That's these sort of short but lots of peaks style is a Venlo greenhouse. So they are very popular because they're fairly efficient. They're modular. They all use similar design structure, so they can be easily expanded on. They are next slide. They have their openings are in the peak, so these are the vents that are opening here. If you notice, the vents don't go all the way to the gutter, right? And for places like Canada, that's really important because we can have snow in the gutter and we can still open the vents, because there's times of the year where it's getting hot, say in March, but you still have snow from yesterday's snowstorm, and if you can't open your vents, you have a serious problem. So Venlos offer a lot of flexibility to the grower. Excellent cooling, natural ventilation with the vents, especially because they're at the peak, they're venting, the air can kind of get caught into the greenhouse and cool it, and hot air can escape out of the greenhouse. So they're an excellent design. Because the peaks are smaller but more frequent, there's less area for wind to catch the greenhouse. So high winds can blow across the surface without damaging the structure. But if you have high peaks like this, or giant peaks, the wind has to go over and around, and it creates actually a lift, and the glass sheets will fly off because of negative pressures. So Venlos are excellent greenhouses that are wind resistant, easy to vent. They also are made of glass, and glass has interesting properties, right? So it has poor insulating capacity, which means that it's going to let heat out, because glass is just a thin layer of glass. I mean, if it's cold outside, it's coming right through the glass. Press your face against a window and you'll see what I mean. So it's conducting the cool temperatures outside into the greenhouse, right? That means also that there's more condensation. So if you have humid air in the greenhouse, it touches the cold glass, the moisture condenses and forms droplets. And you'll notice here I said this is a good thing. For the most part, that is true, because we want to be able to dehumidify a greenhouse. This is often a misunderstood concept. Glass greenhouses are almost always a better growing environment because the grower has access to condensation, which will then remove humidity and prevent fungal disease. Oftentimes when I look at the cannabis greenhouses, I look at them growing in poly houses, and I think your biggest challenge is powdery mildew. How do you control your humidity? You spend a lot of money on dehumidifiers, but if they just built a greenhouse with glass, they would have had no humidity issues whatsoever, or very few. But anyway, so glass is excellent at reducing humidity. It also has excellent light transmission, which is again what we're talking about today. So light is incredibly important. Vegetable growers track their yield regularly because yield impacts their dollars, and they want to maximize their yield. And vegetable growers will spend a lot of money to improve the transmission of light into their crop by as much as 1%. So that doesn't sound like a lot, but if they're willing to spend a lot of money, that 1% can turn into a lot of dollars in terms of their crop yield. So it shows you how important light is. With a Venlo greenhouse, the angle of the roof plays a big role in terms of how much light gets in. Because of the steep light incidence of northern latitudes, like in Canada, across both hemispheres as you move away from the equator, that's really helpful for getting light to penetrate into the greenhouse, reduces reflection on the outside. And because it's a steep angle, condensation that does form will run. So if this is my roof, condensation runs down the glass into the gutter where there's a catch, and then the water runs away. So instead of dripping on your crop, it runs off to the sides. So glass Venlo greenhouses, once again, also prove to be very robust structures. They're also easy to repair. Each one of these little pieces that you see here is a single pane of glass that you can replace if it happens to break. So as far as the angle of incidence, what we're looking at here is the sunlight hitting the glass, right? And over here we see how much light is transmitted. So as your sun gets steeper and steeper and steeper, you get less and less transmission. So that's where the idea is that we're getting more light into the greenhouse because the glass angle is ideal. Let's talk about poly greenhouses for a while, or polyethylene. That's plastic sheeting. And what you see here is a double poly. They're almost always double poly. If you look at the side here, it's kind of bulging out. And that's because there's actually 2 layers of plastic on this greenhouse. And they have these blowers, which will suck air from either inside or usually outside the greenhouse with a little hose, and blow air into the space between those two and inflate it. So you end up with sort of a bubble over your greenhouse. These have excellent insulating properties. This is a cold climate greenhouse. They cost a lot less to heat. You can also attach them, what we call gutter connected. So you got your gutters here. So there's double poly arches here. These are also inflated, and they go as far as you want. So double poly greenhouses are usually inexpensive to build. Glass is expensive, it's heavier. Double poly greenhouses are cheap and relatively easy to build. Plus, because it's polyethylene, the construction doesn't have to be as precise. When you're building a glass greenhouse, you have to have lasers and extremely precise installation of your posts. Otherwise, the glass won't fit when you get to the other end of the greenhouse, and you have yourself a nightmare. So building a glass greenhouse requires a lot of skill, where building a poly greenhouse, just about anyone can build it if you have a step ladder and a cordless drill. So oftentimes companies that are starting out and want a low-cost way to get started will go with double poly for their first range, and then when they finally have some money, they'll build glass. Now this is an interesting picture down here. This is a double poly, what we call apex style, where it's got a pointed peak. Notice this greenhouse is made with, has got white plastic on it. That is not going to let a lot of light through. So it happens occasionally. Maybe they're a crop that only grows in the summer and they have to control heat. But when you are blocking that much light, your crop's going to grow a lot slower and your yields will be a lot smaller. So this is a close-up of an apex style. The nice thing about apex double poly, right, there's your vent, your double inflated vent. They usually vent on only one side, right? But the nice thing about them is that because they've got this peak, just like the Venlo, these are slightly bigger than the Venlo, but they have a peak, is that when condensation forms, it will run down the sides into the gutter. It's more likely to, let's say. Not perfectly, but less likely to drip on your crop. Whereas the Gothic arch style typically struggles and the condensation drips at the top where it's fairly horizontal. So why double poly? They're cheap to construct. They're very energy efficient. Those double layers of plastic insulate the outside cold. It has to go through 2 layers to get to the inside of the greenhouse. But also because they're more insulated, they have less condensation. Or it may not look like that because they always have water on them. But they do less, there's less dehumidification. So typically a double poly greenhouse is more humid. certain crops like cucumbers and orchids love double poly greenhouses. So there's still a place for them, but high humidity is specific to the crop, right? Not most people don't want high humidity. They want to control it. What's the catch? Well, glass has much better light transmission, but polyethylene has diffuse light because when it's not like glass, if you look through polyethylene, you can't see anything. It's milky. That means that any light that passes through it is going to come out randomly scattered. And that reduces shading and stuff like that. That helps offset some of the reduced light transmission. But, you know, they also can only vent in one direction. So depending on how the wind is, they sometimes have to limit it. Otherwise, they risk breaking the greenhouse apart. So if the wind's coming from the wrong direction, then you may have over temp conditions in your greenhouse. Because the vents go all the way to the gutter, snow load can be a problem, right? So you can't open your vents in March necessarily if there's still snow in the gutter, because it will overload your drive and break things or tear the plastic. Condensation drip can be an issue as well because of the shape. I got a couple of slides coming up that will show that. And here's a big one. You have to replace the plastic every 3 to 5 years. So there's a huge environmental impact for that. The plastic can't be recycled, not back into greenhouse plastic at least. So it's typically discarded. And it's a lot of labor to change the plastic. So these are Gothic arch or arch style double poly as opposed to the peaked type. And these ones have a lot of condensation dripping issues. No one builds these anymore, to be honest. They're considered low tech, and you're going to have a lot of, wherever it drips, it's going to damage your crop, and you'll have huge losses that will add up in a hurry. This is condensation drips forming in the top of an arc, and they're dripping onto the crop, and you can see the drips have actually washed out these plugs in these trays, making these trays basically useless. And if you think, well, how many arches are in a greenhouse, and each arch is going to take out that many plants, that's huge. So that's bad. Here's a picture of some people, an old photograph, got the mullet going, pulling the plastic off a greenhouse, and they'll have to pull new plastic on. All that gets discarded. It's a huge amount of waste, not to mention labor. And you typically want to have your crops out of the greenhouse when you do this, so there has to be a break in the crop cycle. So yeah, poly, not ideal. Nice thing about here, we have freestanding greenhouses, we have gutter connected, right? So there's less exposed surface area with gutter connected, so they're more energy efficient. Inexpensive to construct freestanding ones. Freestanding greenhouses don't necessarily need a construction permit. That's kind of handy. You can roll up the sidewalls. You don't have to have a fan if it rolls up high enough. But they have a lot of surface area on the outside, so they're expensive to heat. But you know, it's not a big deal. I'm not going to spend too much time on this. Jay's going to cover that stuff. Then there's talk about the different types of coverings. There's polyethylene, there's polycarbonate, other than glass. There's even some new companies selling sort of like a bubble wrap stuff called Solar Wrap, which is interesting. It's, I would say, as of yet unproven in terms of how long it lasts. But when you're looking at greenhouse coverings, we want to look at stuff that seals the air in, that insulates, that lets the maximum amount of light through, diffuses the light to get better penetration in the crop, less shading. Maybe even will cool the greenhouse in the summer if it's coated for infrared blocking. Reduces UV radiation, which can be damaging to some crops. Will last long, right? And minimize dripping. So a lot of polyethylene is coated on one side and not on the other, and it's important when you install it that you know which side is which. Usually there's a ink silk screen on the plastic that tells you which side is inside, which side is outside. And the condensation coating, all it is a coating that prevents water droplets from forming as large droplets. It makes them small so they spread out. It doesn't change the condensation or the reduction of humidity in the greenhouse through heat conduction, but it does minimize dripping on the crops because it typically runs down off the plastic. And of course, if you're choosing covering materials, it depends on what you're willing to spend, how much light you need, what's your impact of energy versus crop needs. So kind of repetitive there. This is just basically talking about polyethylene versus single, double compared to glass. I think, again, we've covered a lot of that already. And then air inflating double poly, right? The idea is that air pockets act like insulators, and that reduces your heat loss, which is really important. So if you're in the north, if you're in the far north and you want to start a little market organic greenhouse or something like that, you want to go with a double poly greenhouse because it's going to be the most energy efficient because it's so cold. But you should know that every time you add a layer, and I've seen greenhouses that do 3 layers of plastic actually, every layer reduces light. So depending on your crop and its light requirements, you have to be careful. Another look at cucumbers. I've seen cucumber greenhouses that have put 3 layers of plastic on, and they had very, very little heat loss. And cucumbers are able to grow and yield fairly well with lower light levels. And of course, they love the humidity that they get. So that's an interesting crop from that perspective. This is a slide showing you what happens when light passes through plastic or glass. So every time glass or light moves through a different surface. So it's going from air into glass. As it passes through, some is reflected back. And then it passes through the glass, and then when it exits the glass, some is reflected back. And then, of course, less gets through the other side. And if you have water droplets, when it hits the end of the water droplets, some is reflected back. So you end up with a lot less coming through the other side than you started with. So it's important to understand that when you're thinking about multiple layers and how much condensation is in the crop and all that kind of thing. Looking at polyethylene, look how dark it is when you have lots of condensation. You can't really see, but I can tell you there's condensation on the arches here, and it's blocking a lot of light coming through that greenhouse. Now this is a bit unfair because obviously it's a sunny day here, but anytime you walk into a glass greenhouse versus a poly greenhouse on the exact same day in the same location, the difference is incredibly noticeable. Like no one can deny that there's more light in the glass greenhouse. But like I said, depending on your crop, depending on your location, double poly has a place. So that brings the discussion of light introduction to an end. Our next lesson will go into a little more depth with light and in crops and how we interact with them. But anyways, welcome you back. I hope you have a good term, and I'll see you at the greenhouse sometime.